Hi guys, I am Neil and I'm back for my second video tutorial. So this time, we are going to tackle about scheduling algorithms or CPU scheduling algorithm. So scheduling of processes, work is done to finish the work on time. So below are different time with respect to a process. We have here first the scheduling jobs, the arrival time, time at which the process arrives in the ready queue. So when we say arrival time, it is the job which comes first, the ready queue will get the CPU first. Or shall we say, the lesser the arrival time of the job, the sooner we'll get the job gets the CPU. The next is the completion time, time at which process completes its execution. Or shall we say, it is the time taken for the execution to complete starting from the arrival time. So it's very understandable, guys. So the next is the burst time, the time required by a process for CPU execution. The next is the turnaround time. The time difference between completion time and arrival time is turnaround time is equal to completion time minus the arrival time. So it is the time taken to complete after arrival, or in the simplest words, it is the difference between the completion time and the arrival time. So lastly, the waiting time. It is the time difference between turnaround time and burst time. So we have here the formula, waiting time is equal to turnaround time minus the burst time. So it means that the total time the process has to wait before its execution, it is the difference between the turnaround time and the burst time of the process. So let's proceed to the types of scheduling algorithms. We have here the first come first serve and the shortest job first. So we have here first discussed first come first serve. It is a scheduling algorithm that schedules according to arrival times of processes. First come first serve scheduling algorithm states that the process that requires the CPU first is allocated the first. So it means that first come first serve is the process which arrives first gets executed first. Or we can say that the process which requests the CPU first will be the first to allocate the CPU. So if you're a merchandiser in a supermarket, first come first serve is just like a FIFO job, or first in first out. But here in job scheduling, FIFO is a queue data structure where data element which is added to the queue first will be the one who leaves first. First come first serve is a non-preemptive algorithm, which means that the process priority doesn't matter. It is because if a process with every least priority, or least meaning lowest importance or lowest priority, is being executed, more likely a daily routine backup process which will take more time. Then all of a sudden, some other high priority process will arrive. Like for example, a system crash interruption. The high priority process will have to wait. Then the system will crash due to the improper scheduling. Then let's proceed for the tabular presentation for computing the average time of first come first serve. So we have here in the tabular form, we have the process number, arrival time, burst time, completion time, turnaround time, and lastly the waiting time. In order to get the completion time, we can only have the arrival time and the burst time. So let me show you here the exact computation on how this averages is being computed. So let me show you here how it's done. We must need first the Gantt chart. In our Gantt chart, we have here our Gantt chart. We have here the P1, the P2, the P3, the P4, which are the processes. So the arrival time of process 1 is 0. The question here, how much time does P1 required to penetrate? If we considered our burst time is 4, then the answer is 4. We can see here that there's no waiting time here. It's direct. Then the next one, how much time does P1 required to penetrate to P2? So we only have to add the completion time of 4 and the burst time of P2. So the answer is 7. Then to P2 from P3, we also add the completion time of P2 and the burst time of P3. That's why it's 8. Then lastly, the completion time of P3 is 8. The completion time of P4, the burst time of P4 is 2. That's why it's 10. So we are now done in the completion time. Like I've said earlier, it is the time taken for the execution to complete starting from the arrival time. Then the next one is the turnaround time. We have here the formula. Turnaround time is equal to completion time minus the arrival time. So it's very simple, guys. We only have to substitute the value from P1 to P4. So we have here first the P1. The completion time of P1 is 4 minus the arrival time is 0. So the answer is 4. So for P2, the completion time of P2 is 7 minus the arrival time is 1. So the answer is 6. For P3, the completion time is 8 minus the arrival time is 2 is equal to 6. And lastly, the P4, the completion time is 10 minus 3, the arrival time is equal to 7. So it is very easy, guys. In solving turnaround time, we only have to find the difference between the completion time and the arrival time. Because turnaround time, it is the time taken to complete after arrival. So we have here the next one, the waiting time. We have here the formula. Waiting time is equal to turnaround time minus the burst time. So it is very easy again. We only have to substitute the value. For P1, we have here the turnaround time is 4 minus the burst time is 4. That's why it's equal to 0. So like I've said earlier, there's no waiting time in P1. Then in process 2, the turnaround time is 6 minus the burst time is 3. So the answer is 3. Then next, in P3, the turnaround time is 6 minus the burst time is 1. It's equal to 5. For P4, lastly, the turnaround time is 7 minus the burst time is 2 is equal to 5. So in computing waiting time average, we only have to add the 4 processes, then divide it by 4. So 0 plus 3 plus 5 plus 5, 13 divided by 4 is equal to 3.25. So the average waiting time is 3.25. So again, it is very easy to compute the waiting average time, it is because we only have to find the difference between the turnaround time and the burst time of the process. Because total waiting time is the total time the process has to wait before the execution. So we are done now in first come first serve, and now let's proceed to the shortest job first. Shortest job first is a process which have the shortest burst time are scheduled first. If two processes have the same burst time, then first come first serve is used to break the tie. So in short, we still need the first come first serve job scheduling for the shortest job first. To put it into words, shortest job first is simply having the least burst time. So it is actually scheduling among the available process the shortest job first, which means when you are standing at this point of time, only one process which is available is P1. In shortest job first, there are only two variations, the preemptive and non-preemptive. But this time, I will only use the non-preemptive. The non-preemptive, which means whenever a need of job is chosen, it will not stop until it finishes it. That's why it is called non-preemptive. But if you are curious that I mentioned two variations of the shortest job first, I will also give the meaning of the preemptive job scheduling. So preemptive scheduling for the shortest job first is also called as the shortest remaining job next. So we're not going deeper or farther from preemptive because we are going to focus from non-preemptive. So in non-preemptive job scheduling, in shortest job, you will going to run it until completion, otherwise you're not going to stop. Proceed. We have here the tabular presentation for the shortest job first. It's like in the first come first served, we have the process number, the arrival time, burst time, completion time, turnaround time, and waiting time. So for computing the average of the shortest job first we have to assume that our P1, the arrival time is 1. So from 0 to 1. So to compute the completion time for the shortest job first, we have here our Gantt chart. So over here the processes from P1, P3, P4, or P2. As you can see, it is in any order, not in order. So as you can see, there's a 0 at the starting point because arrival time always starts at 0. But in here, in this tabular form, we assume that our P1 has the arrival time of 1. So again, the question here is how much time does P1 require to penetrate the system? So the answer here is 8 because we add the arrival time and the burst time of P1. That's why it's 8. Then in order for us to proceed the next job, the next process, in shortest job, we have to pick for the least available one. So we have here our basis is from the burst time. So we have here the P3. So we pick P3. So from P3, so from P1 to P3 rather, the completion time is 9. You only had had to add the completion time of P1, which is 8, and the burst time of P3, which is 1. That's why it's 9. Then from P3 to the next job shortest is the P4. So how much time will required to penetrate from P4, from P3 to P4? So we add the completion time of P3, then from P3, how much time is required to penetrate from P4? So we add again the completion time of P3 and then the burst one of P4 burst time. So we have 11. Then lastly, we have here the P2. We have 16 answer. We add the completion time of P4, which is 11, and we add the burst time, which is 4. That's why it's 16. So we are done in completion time. We have to proceed in turnaround time. It's the same with the first come first serve computation. You have to find the difference. You have to find the difference between the completion time and the arrival time. It's very easy, guys. The completion time of P1 is 8 minus the arrival time. That's why the turnaround time is equal to 7. Then for P2, the completion time is 16, then the arrival time is 2. That's why it's 14. Then next is the completion time for P3 is 9. Then the arrival time is 3. So 9 minus 3 is equal to 6. And for P4, the completion time is 11 minus the arrival time is 4. That's why the turnaround time is 7. Then let's proceed lastly for the waiting time. In order to get the waiting time average, we must have this formula again. Turnaround time minus burst time. So P1, turnaround time is 7 minus the arrival time is 7 is equal to 0. P2, 14 minus the arrival time 5 is equal to 9. P3 is equal to 6 minus 1, the arrival time is equal to 5. Then lastly, P4, the completion time, turnaround time is 7 minus the burst time is 2. It is equal to 5. So to compute the average waiting time, we have to add the processes 0 plus 9 plus 5 plus 5, then divide by 4. And the answer is 4.75. And that's all for this tutorial. See you again for the next video tutorial.